Before I start this video, let me take 30 seconds to tell you something about Exergic. Exergic is India's most trusted and most experienced institute for online GATE preparation. I am Chandresh Mahajan, founder and chief educator at Exergic. I am an All India rank 37 in GATE Mechanical Engineering, an ex-Indian Oil officer having 7+ years of teaching experience as of now. These are the GATE 2021 Mechanical Engineering toppers from Exergic. You can find their preparation strategy on Exergic's website. To know more about our GATE courses, you can visit our website or contact us on these details. Also, you can download Exergic GATE preparation app from Google Play Store. The link is available in the description of video. So the concepts that we discussed so far, I told you that for pure rolling without any kind of slipping at the point of contact, what should be the condition? At the point of contact, what is the condition of pure rolling? The condition is that V naught should be equal to R omega naught. Only then it will be having zero instantaneous velocity. It will be at rest, right or not? So what do the students think? That for pure rolling, always at the point of contact, V naught should be equal to R omega naught. This is also slightly incorrect concept. Why? And in which case will they be different, but still there will be pure rolling? Look, the better definition, as we are moving ahead into the discussion, we are going to study it in more advanced forms, right? The better way of saying pure rolling would be that at the point of contact, the relative velocity should be zero, or the relative instantaneous velocity of the rolling body with respect to the surface of rolling should be zero. Did you understand what I told you? That the point of contact may not be at rest. It is possible that point of contact will not be at rest. The body will be having certain velocity at the point of contact, but that velocity should be same as the velocity of the surface on which it is doing the rolling. If there is a body doing pure rolling, all right, but it is not doing pure rolling on a surface which is at rest, rather it is doing pure rolling on a surface which is moving. Like in this case, this body is suppose doing a pure rolling, but it is doing pure rolling on a surface, on this trolley which is moving in this direction, right? So in this case, look at this point here. This is the point of contact, right? What do you think? Is this point having zero velocity? No. This point is having a forward velocity of Vt, because this point is lying not only on the body but also on the trolley. It is moving forward, right? Single point cannot have two different velocities. So clearly this point of contact has a velocity of Vt in the forward direction, right? But you will think that, sir, you told that point of contact should be at instantaneous zero velocity. That is instantaneous zero relative velocity. Relative with respect to the surface on which it is rolling. If it is rolling on a surface which is moving at 10 meters per second and the point of contact also has a velocity of 10 meters per second, then it is also pure rolling. So one more definition I have added for pure rolling. I told you a very good MSQ question can be made on just on the definition of pure rolling, right? 4 different options can be framed. It will be a very basic question, but I am telling you students will do mistake in that. So add this into the definition of pure rolling, that if the point of contact has zero relative velocity in a body which is rolling, then that body is also performing pure rolling. Now have a look at this case. Suppose this is the body. It is rotating with the angular velocity omega naught. Its radius is r. So suppose you have this case where you have a rolling body which is doing pure rolling on a trolley, and initially consider that the velocity of trolley Vt is zero. Initially consider this is not moving. So trolley is just like a flat surface at rest, right? So when Vt will be 0, tell me, for pure rolling, what should be the velocity at point A for pure rolling? The velocity of point A for pure rolling should be equal to 0. Instantaneous relative velocity. Trolley is also at rest, so the velocity of A should also be at rest, 0 velocity, because relative velocity between them should be 0, right? And when this velocity of A will be 0, when V0 will be equal to R omega naught, right or not? Velocity of A, what we can write? V0 minus R omega naught. I have already told you how do we find this. V0 is in the forward direction, so here V0 will be in the forward direction. Omega naught will give a velocity in the backward direction, R omega naught, right? At this point A, it is trying to rotate like this, so the velocity, tangential velocity due to omega naught will be in the backward direction, like this. This is going to be R omega naught or omega naught R, right? So velocity of A will be the difference of both of them, and it should be 0. Because Vt is equal to 0, instantaneous velocity at A should be 0. So we can write that V0 is equal to R omega naught. When Vt is equal to 0, obviously this case, both the cases, second one also, will be for pure rolling. So in this case, V0 is equal to R omega naught is true when Vt is equal to 0. But suppose Vt start moving, the trolley starts to move. Now Vt is not 0. Now tell me, suppose a question came in GATE, a very 1 mark question, where the radius is given, velocity is given, omega naught is asked, V0 is given, omega naught is asked, Vt is also given, yet it is having some velocity. Will you use V0 is equal to R omega naught to find out the omega naught from V0? Can you apply this expression when Vt exists, when Vt is not equal to 0? You cannot apply this expression. When Vt is not equal to 0, it is moving and still velocity of A is 0. What does it tell? It tells that this rolling body, point A, will stay here only, because velocity of A is 0. So point A will stay here only, Vt will exist. Will you call such motion pure rolling? There is a platform which is moving forward, but point A is with respect to rest at the same place. Will it not happen that platform will move ahead and this point will stay there only? This is a platform, okay? This is the trolley. This is the sphere, okay? Point of contact between them is this one. When point of contact is having 0 velocity, because we are saying that no, V0 is equal to R omega naught will be applicable, which means point of contact will be having 0 velocity. If this point of contact is having 0 velocity and this trolley is moving forward like this, is this a rolling motion? I don't think it's a rolling motion. Even if this body is moving forward, but the bottom point is still at the same place, it is not moving forward. This is not pure rolling, right? In pure rolling, it has to move forward such that the bottommost point or the point of contact and trolley should stick together. They should be like they are stick together. Both of them are moving with the same direction. It is rolling forward also. But if it is rolling in such a way that trolley is moving forward, but the bottom point is still at the same place, this is not going to be pure rolling, right? A basic difference. So how do we write the equation in this case? In this case, as I told you, the bottom point should have the same velocity as the trolley, as the surface which is moving forward. So at the point A, velocity of point A, which is V0 minus R omega naught, should be equal to Vt and not equal to 0. And if point A is moving forward with Vt and surface is also moving forward with Vt, then the relative velocity between them is 0. This is the condition of pure rolling, when bottommost point is also moving forward. So this expression, in this expression, V0 is not equal to R omega, but it is the expression of pure rolling. Getting? Suppose a question came in GATE that for pure rolling, always V0 is equal to R omega naught. At least 50% students will take it correct. Simple, V0 is equal to R omega naught, very easy, right? But it's not true. It is true only when the surface on which it is rolling is also at rest. Otherwise, what you have to do? Simple, apply basic vector knowledge. Point A velocity in the forward direction should be how much? V naught minus r omega naught. That velocity in the forward direction should be equal to Vt. The arrow is also important. You cannot write omega naught r minus V, because omega naught r minus V naught is in this direction, Vt is in this direction. Relative velocity 0 means not only magnitude but also direction should be same. So you will consider V naught, then you will consider minus omega naught, because V naught minus r omega naught will be in this direction, right? Basics of vectors. At point A, V naught minus r omega naught, if I write as a vector, it is in the forward direction, in this direction. If I write r omega naught minus V naught, it is in this direction. Basics of vector we have already discussed in mechanics, right? So we need to have the velocity of point A, the subtraction of V naught and r omega naught in the forward direction, in the same direction as Vt. So we have to write V naught minus r omega naught and not omega naught minus r, omega naught r minus V naught. What the point? So at point A, forward direction velocity, which is V naught minus r omega naught, should be equal to Vt. A very simple concept, but I took time to explain this concept, mainly because, let me be very frank here, and actually I have told this to you already in the mechanics, that mechanics I teach by assuming that you know nothing about class 11th mechanics. I do not consider any small concept of vector also that you know already. I teach everything in mechanics and almost in every subject from the very much basics. That is why you may feel that, sir, you are explaining it in so detail and all, but it is necessary because not all of us are at the same level, right? That is why you have the feature of watching it in high speed, fast forward. So if any stretch, suppose you are from a very good college, suppose you are an IITian who has secured a very good rank in IIT JEE, and these all things seems very basic to him, you can forward the video means you can watch the video at a faster speed. Don't skip anything. I keep telling small tips here and there which will benefit you a lot. So please do not skip anything. Even if you know it, you can watch it at a faster speed of playback, but please do not, skip something. So this expression can be used. Consider this case. In this case, omega naught is in this direction. V naught is in this direction. Now in this case, at point A, V naught will be in the backward direction, but omega naught is rotating like this, so r omega naught will be in the forward direction, right? R omega naught. At this point, if I want to write velocity of A, the better way to write it would be r omega naught minus V naught, right? Velocity of A in this direction, r omega naught minus V naught. But when Vt is 0, this has to 0, V naught and r omega naught should cancel each other, velocity of A should be 0, same as the surface velocity. But when velocity of T is not equal to 0, then what will happen? To ensure pure rolling, velocity of A should be equal to surface velocity. The relative velocity between them should be 0. Surface velocity is Vt in this direction. So r omega naught minus V naught should be equal to Vt. R omega naught minus V naught is the velocity of A in this direction, same as Vt, not only in magnitude but also in direction. How did we consider direction? By putting r omega naught first and V naught second. If we put V naught first and r omega naught second, then we are considering this direction. Got the point? So these are two cases I have shown you. Very simple cases. These equations, these are the very much fundamental equations. But if a question in GATE comes, many people will do mistake in this. Some will not be able to understand that V naught and r omega naught will not be 0. Some will be able to understand, but they will not be able to understand that r omega naught has to put first and then V naught has to come. So small things are there. Silly mistakes are possible, but knowing this not only makes your concepts stronger, but also makes sure that if such question is asked, you will be able to solve it. So far we have discussed that rolling motion is a composite motion, how these two motions occur, how they are related to each other, what are the different types of rolling, and how can we analyze the velocity of any point in rolling motion, right? Using the vector analysis, how velocity, acceleration, etc. we can find out. And now is the time to discuss about the forces and the torques and their effect on a body performing rolling motion. Now, before I discuss anything, I want you to understand that whatever discussion we are going to do now onwards, will be for pure rolling only, right? For rolling with slipping, I will discuss it separately. I will tell you that now we will start slipping and rolling simultaneously, then we will discuss it. But now onwards, whenever I say rolling, it automatically means pure rolling. I do not have to separately say pure rolling, and this is true for your questions as well, for your discussion as well. Whenever in a numerical question it says rolling and it does not mention anything about slipping, means it is pure rolling. Question will not specifically add pure word every time. Alright, so this is true for my discussion also, that whenever I am going to say rolling now onwards, if I do not mention anything about slipping, it is pure rolling only. Got the point? Now, we are going to now discuss about torques and the forces, and that discussion will not be done without Newton's law of motion, right? Newton's law determine that how forces and acceleration are going to get related to each other, and how forces exist, whether they exist or not. And same we can say for torque as well, right? For translation motion, we can define that if a body is moving with without any external disturbance, without any external force, then it will continue to move with the same velocity, right? Its state will not change. If force acts, then it will accelerate, its velocity will change, and how they will change, it is related by the second law. In a similar way, for rotational motion, if a body is performing angular motion at constant velocity and we are not applying any external torque, either to support or to oppose, then it will continue in the same angular velocity, right, without any angular acceleration. This is Newton's first law for rotational motion. But what about Newton's law for rolling? We can combine both of them to put out the Newton's law for rolling, because rolling, as I have told you, is the combination of translation and rotational motion. So we can say that a body which is performing pure rolling, its velocity, linear velocity of center of mass, will not change, and its angular velocity also will not change if there is no external force and no external torque acting on the body. It will continue doing the pure rolling till the end of time, right? Obviously, it's a hypothetical situation. In reality, some friction, some torque will exist which will decrease the velocity and angular velocity, or if you support it, it will increase it. So this is the Newton's law for pure rolling. And from this we can conclude that when there is no external torque and no external force acting on the body, then there will be no linear acceleration, no angular acceleration, right? So force net which is acting on the body is 0, so acceleration is 0, and torque net is 0, so angular acceleration is 0. And this condition in case of rolling is called as uniform rolling. So uniform rolling is nothing but uniform translation plus uniform rotation. Uniform translation, this is the condition. Uniform rotation, this is the condition. Right? Combine them together, you have uniform rolling. And now since we are talking about uniform rolling and we are going to talk about the forces acting, so whether you apply some force or not, there is one force which is a free gift from the God, friction force, right? It is going to act on the earth. And now is the time when we will orient our discussion towards the friction, right? Rolling friction being the latest addition in GATE 2021 onwards. So this is the time where the discussion about friction will start. Okay, and let me start this discussion with a very interesting question. Tell me that for the case of uniform rolling, means this body is moving with a constant angular velocity and constant linear velocity. No change in them. No linear acceleration, no angular acceleration. And now tell me, what will be the direction of friction for uniform rolling? Again, I am telling you, uniform rolling means pure rolling is embedded into it. Rolling automatically means pure rolling if slipping is not mentioned, right? So uniform rolling, for this case, tell me that where should friction act in this case? Let me tell you what many aspirants think. And I know it because I keep solving their doubts. I interact with them in the premium group. So I have a good idea of what they think and what mistakes they make. Look, they think that, sir, this body is rolling, right? It is rotating like this. So the part of the body is coming here and going above, right? It is coming here and going above because it is rotating like this. So, sir, at this point, the part of the body will try to move back because it is, sir, moving back like this. So at this point, sir, it will try to go back. And since it is trying to go back, friction will act in this direction, sir. Friction will try to oppose it, sir, because it is trying to move backward. Friction will act in this direction, sir. This should be the direction of friction. Only then it can move. Otherwise, sir, at the same place it will keep on rotating, sir. Friction will stop it like this. Then only it will roll ahead. This is the logic that many of you guys have, which is incorrect. This is not the direction of friction. So does it mean that friction will act in the opposite direction like this? That is also not the direction. The right answer is that friction will not act in the case of uniform rolling. Why? I will give you two different ways. I will conclude this from two different ways. The first way is that consider this part of the body. Okay? Zoom into this part of the body. And suppose this part of the body, this shaded part, is that part of the body which is in contact with the surface, which is the point of contact. I have already told you that point of contact is instantaneously at rest. Point of contact is not trying to move anywhere. If this is the point of contact, suppose this is the curve, this is the point of contact. And this point of contact, when it comes in contact with the surface, it is not trying to move anywhere. It is not having any velocity relative to the surface. Relative to the surface, it is at rest. It is not rubbing against the surface, not slipping on the surface. It is at rest with respect to the surface, which means there is no friction. Friction will come when they are rubbing together, right or not? When there is a relative motion, then the friction will exist. But since it is at rest relative to the surface, then what will happen? No friction force will act. So friction force has to be zero in the case of uniform rolling. This is one way of proving it. Let me prove it by another method. And the another method that I am going to show you right now is important. It is important because the way I will prove it, the translation and rotational analysis that I will do, it will help you in many of our further discussions. That is why I am giving you one more way of solving it, one more way of proving it. Otherwise, from this discussion that I have told, it is very much clear that at the point of contact, no relative velocity, no relative motion, hence no friction, right? And some of you can think that, sir, how can you say that friction will not be there, sir? At rest, even friction can act. Yes, I know it can act. When we apply some external force, there is a body resting on a surface, and we apply some external force such that force is less than the maximum limiting friction, then it is true, right? This is we have discussed in friction. But in this case, we are externally not applying any force. So this concept, if you want to use here, you cannot use. We are not applying any external force on the body. Friction, we are not applying, right? Friction is the result of the relative motion between them if it is happening. We are not applying any force. So that funda you cannot use. That's why even at rest, the force can be cancelled by friction. So we can say that friction can exist. That funda cannot be used. Got it? Let me prove it by another method. If you think that no sir, I am still not convinced friction can act, then let me prove it. Let's consider this direction of friction. What we are going to do, we will consider this friction direction and we will analyze whether it is feasible to have this direction of friction or not. And I will show you that it is not feasible. Then we will take this opposite direction of friction. And I will show you that it is not possible to have friction in that direction as well. So if friction cannot act in this direction and in this direction, then it cannot act, right? Friction cannot act perpendicular to the surface. Friction has to act along the surface. And since it is a 2D plane and 2D analysis, friction will either act in this direction or act in this direction. If both the directions are not feasible, then friction will not act. Getting the point? So let us first take this case when friction is acting in this direction. And now let us analyze the rolling motion. This is uniform rolling, right? So V of center of mass is equal to R omega naught, or V of center of mass divided by omega naught is equal to R. This is the condition of rolling that we have, pure rolling. Now look at this case. We want to do the analysis of this body. I have told you that for rolling, we do the separate analysis. The analysis of translation will be done by assuming there is no omega. Forget about the rotational part. Just think this is a body which is translating. Force we will consider, velocity we will consider. And when you do the rotational analysis, then forget about the translation motion. Then forget that there is any linear velocity. Only consider the omega and only consider the torques if the force is producing any torque. So here, the translation analysis, what it will tell you? Translation analysis tells that velocity is already in this direction. Force is acting in the same direction. What happens when a body is moving in a direction and force acts in the same direction? It accelerates the body. The velocity increases, right or not? So if this is the case, velocity is going to increase. This will increase. And now come to rotational part. In rotational motion, forget about the velocity. Just consider omega and torque. This friction about the center, right? Omega is about the center. So this force about the center will create a torque like this. This torque is in the opposite direction of omega. It is acting like this, opposite of omega. This torque and omega are opposing each other. Omega is in this direction, but torque acts in the opposite direction. Such a torque will reduce the angular velocity, right? Any torque which acts in the same direction of omega increases it, and which acts in the opposite direction decreases it. These basics we have already discussed, right? I am not going to explain this whole rotational motion here. These are very much basics which we have already discussed. So since torque and omega are acting in the opposite direction, omega will reduce, omega naught will reduce. Or in this expression, numerator will increase, denominator will decrease. Now answer, will this ratio remain a constant? For pure rolling or for rolling, the ratio of V center of mass and omega naught should be a constant. If this is doubled, this should also double. Then only you can say that pure rolling is happening and rolling is happening, right? But if numerator is increasing, denominator is decreasing, so ratio will not remain constant. Ratio will change. And if ratio changes, the motion will not be a pure rolling motion, right or not? Hence, for pure rolling, again I am telling you, don't think that sir, how pure rolling, why not slipping? Don't think all of that. Slipping will be done separately. Whenever I say rolling means pure rolling only. This is uniform pure rolling. Pure is not written, but it is pure rolling only, right? So for this case of pure rolling, when friction acts in this direction, it cannot sustain pure rolling. It will no longer be a pure rolling. Hence, it is not possible that pure rolling is happening and friction is present in this direction, because it will disturb the balance of pure rolling. It will no longer keep it as a pure rolling, right? And now let us assume the opposite direction of friction like this. If friction is acting in the opposite direction, now it is going to decrease the velocity. Velocity is in this direction, friction is in this direction, opposing it. So this will decrease, and this friction about O is going to cause clockwise friction torque. And this clockwise torque will support omega. It will increase omega. So numerator decreasing, denominator increasing. Again, the ratio will not be constant. Same problem, right? Similar problem. In the previous case, numerator was increasing, denominator was decreasing. Now numerator decreasing, denominator increasing. Ratio will not remain constant in this case also. Hence, friction cannot act in this direction as well for pure rolling. So friction neither can act forward nor can act backward, means friction will not act in the case of pure rolling. So the second way that we discussed, how we analyze translation by forgetting about rotation and analyze rotation by forgetting about translation. This is important to note. And also note that how, in order to sustain pure rolling, V and omega should vary simultaneously with the same rate. If you have a system of rolling where force is causing some random variation of velocity, omega is varying randomly, then pure rolling cannot be sustained. Pure rolling will sustain when V and omega are varying simultaneously with the same rate. Whatever is the loading, whatever are the forces and torques, they should act in such a way that they do not disturb this balance of V is equal to R omega naught. Now I think you have started to see that this equation is important, is beautiful equation, right?